the requirements, right? So when you go to the room for interview, or when you join a Zoom call or Teams call, and you are given a question about a particular design, the first thing people should be doing is scoping the requirement, which most of the people doesn't do. It has few steps basically. There are two parts of it, which is called the non-functional and the functional. Okay, so the functional covers the aspects of what are the features it will have, right? Look, suppose a Twitter, right? So the functionals will be like user can tweet, a user can view his timeline and the tweets from the other ones. It can follow, unfollow, it can retweet a tweet, and now if the edit is there, like you can edit and all that, right? So those are the functionals. Now there will be another aspect of it, is that the non-functional, which is pretty much common in any high scalable problems or any high scalable design, where it needs highly available, like you need to have 5 nines, what we call 5 9 or 7 nines. That means it can be down for 1 to 2 seconds in 1 year. Okay, so the non-functional will cover most of the common things like availability, scalability, high performance, low latency, right? High throughput. So those will be the part of the non-functional. So you always, whenever you get a design question, you always start with two things, scoping the requirements, and that scoping requirements will have that. Now you might be thinking that, why the non-functional is important. The non-functional, of course, people know that there is availability, scalability that must be applied to any kind of design. But there are certain scenarios where the company choose to have more secure application or more reliable applications than higher speed or the less throughput, right? I mean, this less latency. For example, for a Facebook or for a Twitter or for Amazon or a Flipkart, for them, okay, let's talk about the Amazon first. Okay, Amazon or Flipkart. For Amazon and Flipkart, what is the most critical point? I mean, for them, it is the availability, that their system should be highly available. That is one thing. And second is, it should load very fast. It should be very low latency. Why? Because just assume you want to buy a phone, right? And you visit an Amazon website, right? And you search for a particular phone. That page is taking little longer time to load all the different types of versions of it. You check the reviews, it's taking a little time to load those reviews. By the time you see that, okay, you go to checkout, it's still loading, and then you kind of got fed up that, hey, let me get to the Flipkart, and Flipkart loaded pretty fast, and you basically went through, browse your phone quickly, and you saw the similar price, unless there is a big difference in prices. Of course, then you will still wait for the Amazon. But if the prices are pretty similar, you will still go ahead and buy the phone, just because of the little latency problem, right? So there, the latency is pretty critical. But if you think about the banking solutions, right? So banking solutions, suppose SDFC or Citibank or anything, you might be seeing that it is pretty slow compared to the other websites, right? So if you try to get the statement, if you try to load something, if you try to check the account statement, it's pretty slow, but it is highly reliable and highly secure, right? So your application might have certain requirements, and if you're designing a banking solutions, your interviewer might tell that, hey, I'm okay to have little higher latency because it's a bank. It's not like today you are I am loading the page little slower in SDFC, tomorrow you'll go and open the bank in somewhere else, right? You will not do that. I mean, that's not something people generally do, that you just have a patience, then you wait for your statement to come, load, do a transactions and all that, right? So they focus more on security, they focus more on validations, they focus more on reliability, the atomicity of the applications. But for e-commerce company, it is the availability and the low latency. Now, if you see the banking, right, they have high requirement of the data integrity, like their data should be always up to date, the transactions, their Not a single rupee should go from here and there, right? So for them, the data consistency, integrity are super critical. But now think about Facebook or Twitter. Do they really have something like a strong consistency of the data? No. They can wait that if you have done a tweet just now, if it takes a minute to appear on others' timeline, it's perfectly fine. If they're still seeing the older timelines only, that is also perfectly fine. For them, only one thing matters is the availability. For them, consistency doesn't matter much. So if you have done a tweet now, if you have liked a comment now, that not necessary that it should reflect immediately to all the followers. Even if it takes a minute, it's perfectly fine, because for you, still other feeds are loading, and you might not be aware whether Virat Kohli has done a tweet or not, until it appears on your timeline or you visit their timeline, right? So for them, availability is the super critical thing, right? For banking, data consistency or the data integrity is the more critical thing, right? So it is very, very important that you talk about the non-functional requirement as well, that what are things they want to have it in their applications. Why it is needed is that you can choose what kind of solutions or what kind of softwares or tools you will be using in your design, right? It will help you that, okay, if somebody want little lesser consistency, I'll go ahead with Cassandra or Elasticsearch kind of databases. If somebody wants higher consistency, strong data integrity, I'll be using MySQL or Oracle databases, right? If the application is more of a read heavy, I'll be using more of a caching layer. If it is a write heavy, we'll be using something like a Cassandra or file based or S3 bucket if it is a more big size data. So it will definitely help you to choose the technology, and not only choose, once you choose those technology, it will help you to justify also that, hey, as per our requirement, as we have already discussed before, we know that we need a read heavy application, so I'm using cache here. Or point comes is the estimations. Now the estimation is very crucial, as crucial as the scoping. Now estimation, what all things you will do? So you got that scoping done, that, okay, hey, I'll have a user who will be tweeting it and do all these things. Now you are done with all the functional, non-functional. Now you have to do the estimations. Estimations will be DAU. How many of you know what is DAU? Anybody know about DAU? What exactly DAU is? Let me open the chat also. I'm not able to see this.
Daily active users.
Yeah, absolutely. So let me just pop out the chat here. Okay. So so DAU is called the daily active user. Any startup, okay, when any startup, early stage startup, when they go for the funding, for them, the only one metrics is important, which is called the DAU, and there is a certain definition to it. The number of actual users in the system who have registered is different from the DAU. So DAU is, there is a definition, it varies from organization to organization, company to company, on the definition that, what will be the parameter and criteria for defining a DAU. But in an average, a DAU is called that, any daily active user is who has logged in last 7 days, or it could be a definition that any daily active user are who has placed an order on that platform in last 10 days or 15 days, or it could be a definition of anybody who has logged in past 7 days twice or thrice. So these are the definition of daily active users. It is different from the total registered users. And when you go for a funding in a startup, they check for the DAU. And that is why you might be seeing that startup gives a lot of promotional offers, discounts, because they want you to keep ordering, keep logging into their systems, keep using their apps. And that is where their valuation goes up, and that is where they get their valuations and funding. And you might be seeing that you might keep getting the offers on Swiggy initially, and once they get a good funding, once they start making the profit and all that, you might be observing that those discounts and profit promotions starts dripping down. The card offers and the promotions, promo code keeps getting down and down, right? So that is what DAU defines, and it is very crucial that you should be knowing about that. Okay, what will be the average DAU for a particular applications. Then you talk about the traffic. So in the traffic, there could be various types of traffic. One will be the read traffic, where people will be reading. Then there will be a write traffic. Then there are active and passive traffic as well. The active traffics are which are generated by the real users who are basically hitting your API to check the account status or check the few other things. Passive traffics are system to system. So you could have multiple microservices running, and if one microservice needs some information to do some estimation, it may call your microservice to get the same data which you might be serving to the outsiders as well. So you need to think of both the kinds of traffic, whether it's active and passive, and you need to consider both. Also segregate the read and write. Then in the terms of read and write, you also focus on what will be the percentage of the read versus the write. That will help you to decide whether it's a read heavy applications or a write heavy applications. Now, in the read also, what happens is generally a thumb rule in the internet. There is a rule, I forgot the name. It says that 80% traffic is for 20% of the data on the internet. So on the internet, the entire traffic, what people get is get for only 20% of the data. So that is where the cache is pretty effective, and that is where you should be using the cache. We'll talk more when we discuss about those points in detail for taking some of the use cases like tutor design or any other system design problems when we'll be taking the use cases. So you talked about the traffic, you talked about the DAU, then you talk about the kind of data what will be writing. So if it is a read data, you talk about what kind of data it will be, whether it will be a file or whether it will be a JSON, right? So you define the data size of it, and it will help you in estimating the putting the estimation of how much data you will be using it, right? And what kind of databases you will be using it. It will also help you in order to define the cache capacity, that okay, how many clusters you will be needing, and then you also talk about the how many traffics you will be getting in terms of a total this one, the total traffic. So there will be read and write, and there could be various others, right? Like you will have a put, you will have a delete. So overall, what will be the daily traffic? That will help you to do the estimations on how many nodes you will be using, the cluster nodes, like apps, right? How many Tomcat instances or how many web servers you will be using, how many load balancers, and you will be also asking about the availability and scalability aspect of it. So if you're talking about more and more availability, you need to have different data centers. So you need to have your application scattered into the multiple data centers as well. Okay, so once the estimation is done, then you talk about the other details, like when you start talking about, okay, fine, I have gone through the estimations, I've gone through the scoping of the features. Then you draw the basic minimal HDL, right, where you define the components, and this should be as basic as possible. Do not try to complicate, do not try to make it pretty complex at the beginning only. Try to simplify and solve the problem first, right, for some small scale of users, and then you keep on improving by discussing with the interviewer, and then go about it. That will be anyway talk about. And as you draw these things, you take the name of a particular technology or a software. What you do is you talk about the trade-offs of using this, that hey, if you are going to use the Cassandra, you will have to jeopardize with a little bit with consistency. So I think as data is not really important, it's more of a monitoring data, I think we should be using Cassandra here, and that should be fine. For account related information, you'll say, yeah, as data is really important here and the transactional data we need, so we'll be using MySQL here. But it will have a little problem in scaling because it is not really as scalable as Cassandra and all that, and also there will be challenges in the availability. We'll have to have little expensing setup for MySQL as well. So these kind of trades off we will be talking, and don't worry, we'll be having the lot of use cases and a lot of discussions around it, and that's when we will go. I'm more giving you the points what we should be addressing when you take the design interview. Okay, so these are the main points which happens, and then be communicative in the design interview when you give the design interview. So don't be under communicated, don't be under, don't be over. Okay, this is also a big no. Okay, you have to keep it in moderation. You should not be like you are, you are given so generally I have seen many people, right, when I ask a question, they just turn back and they'll start writing everything, and they'll say, yeah, I'm done, I'll explain these things. That is also bad. And this is also bad that you before writing everything, you're asking interviewer that, okay, hey, I'm thinking use this, okay, I'm thinking I'll just use this direction, I'll use this software, I'll use this cache and this. Do not be over communicative also, don't be under communicative also. Just focus on the points where you really need to discuss something, and then you go ahead, get the affirmation and proceed. So